If you call 2 people a long line, maybe it's a medium line. But yes, my father and my grandfather, both engineers. Got my PhD at ASU. Is anyone from Phoenix here? Good for y'all. So I do research on ionic liquids for battery applications, mostly as electrolytes, and then on high temperature molten salts for molten salt nuclear reactors. I do a lot of molecular simulation. It's neat. Okay, about y'all. It's y'all because I'm from the South. So, you are in an exciting time in your life. You're freshmen. You're all very fresh. I can feel it coming off of you. Which is kind of cool, right? Because right now you're making big decisions, and particularly, what are you going to do with yourself? What are you going to study and major in and do? And we are trying to help you make that decision. Part of the point of this class is to try to help you decide whether to continue in the chemical engineering major, for one. You also come from different backgrounds, you have different levels of presentations, different strengths, all of those things. Some of you are going to actually find this class pretty easy. To those of you, I'll just say it does get harder later. Some of you will find this class challenging though, especially in a couple weeks when we get to balances. And to you, I want to say there's nothing bad about that necessarily. Math and science and problem solving are skills that you can learn. And not everyone is just gonna say, oh, I'm a math person off the bat. And so others are gonna struggle with sort of general collegeness and time management and getting things done. Every semester I've taught so far, about halfway, 3/4 through the semester, I discovered that there are a few students who just haven't done anything, who've turned in basically nothing or only a couple assignments. And when I talk to them, I usually find that they are having issues with sort of often the transition in college, organizing their time, getting things done. And I can sympathize. So that is why there are various resources to help you at this time. I'm going to talk about a few of them right now. Okay, you have an academic advisor for the College of Engineering. Those of you who were here for new student orientation have met him. His name is David Okeson, and I wanted a photo of him, but he did not have the photo up on the website. So I just took the placeholder they had, and I put kindly uncle on it, because he is very much a kindly uncle type, and he is very easy to talk to. He will help you with scheduling and planning, any kind of course planning things. He's very useful for that. But he can also help with getting you in touch with campus resources like counseling, tutoring, things like that. You can also always talk to me. Here's David's contact info here, which you can get off of these slides later. And yes, by the way, who knows where the chemical engineering offices are? Okay, some of you. The new engineering building, which you can go into, there's construction stuff happening on front, but you can go up through the front stores, and you go up one floor, back left, that's where we are. All right, student organizations. These can be very helpful for, among other things, helping you to explore the different areas of chemical engineering, decide what you want, get involved, meet people. The American Institute of Chemical Engineers, or AICHE, is the biggest chemical engineering organization on campus. It is a nationwide professional organization. Getting involved in AICHE can really help people launch their careers. We also have chapters of the American Nuclear Society, the Society of Petroleum Engineers, and the Society of Biological Engineers. Those are all national organizations. You have to pay a membership fee, but they can help you learn things. The Biomedical Club, for people who are interested in biomedical engineering, it's very interesting. And the Society of Women Engineers and the Society of Hispanic Professional Engineers both have chapters on campus. And I just wanted to highlight a few organizations that are more hands-on. some people only really get excited about engineering if they can do hands-on things. There's the venture factory for people who are interested in invention and entrepreneurship. Global engineering outreach. So at GEO, they go to the Navajo Reservation every year to put in place an engineering project to make life better there. Upperclassmen can also take the class and then go on a trip to, it's usually Peru, to implement a project there. And then 2-foot prosthetics, which is about designing and creating cheaper prosthetics for the world. And here is the faculty, and I encourage y'all to look people up and look through. If you're in 191, we're going to do a Meet the Professors thing later, but we cover a wide range of research interests among the faculty. We also encourage undergraduate research more than many other institutions. It's a really good way to explore some area that you're particularly interested in, like nuclear science or biology or combustion. If you like studying fire, those big things. We have a few combustion guys. So yes, I would encourage you to go to our faculty page, look around, and most of these guys are very happy to talk, though some of them are quite busy. All right, let's talk about the syllabus now. If I can find, there you go. Okay, so where is this? This, if you look at the URL, it says ionic.byu.edu, and then this came in on 70 index.html. But if you don't want to remember all of that, you can just go to ionic.byu.edu and then go to teaching, introduction to chemical engineering, now you're here. Okay? All right. So, I just want to point out the most important things for you to know right now, and then maybe a few minutes for questions, and then we're going to spend the last 25 minutes, half an hour of the class talking about actually engineering. So, a few things for you to know. There we go. Okay, the syllabus, all right? So here's me, here's my email address. So, and by the way, I use this site for most things. Learning Suite, I'm going to use, you can go there to look at your grades. Grades will be inputted there, all right? But most things I use this site. Okay, my email address. Office hours, Monday through Friday at 10 a.m. Is there anyone who can't make 10 a.m. any day? All right. Do you have a class every day at 10 a.m.?
Yes, ma'am.
Okay. Is it math?
Chem 111.
Chem 111. Actually, who's in Chem 111? Okay. All right. I do not want to have office hours at the same time as Chem 111 because I like it that you're taking it and not 105, and I want to reward you. The only other time I can do every day is 5 p.m. So let's do a vote. The options are, my office hours are at 8 p.m. every day, or I come up with different office hours for every day. 5 p.m. every day, raise your hand. Okay, let's do that. And I will change that to update it. Next, the TAs are here. They do not have office hours yet. We will assign them. We want a good spread. All right, so that's going to be in a week. Luckily for you, first homework's very easy. But let's see, who is here today? I believe only 2 of them are here today. So Connor, will you wave? Everyone look at his face. See him? Hi, Connor. And then Hal. Hello, everyone. Yes, they will have office hours eventually that you will come look at. Okay. We have the course objectives. So the most important things for you to know. Okay, this schedule, it has the topic of the lecture. This is reading in your book that's related to the lecture that you can read to get a deeper understanding. This is the homework that is due. So there is a homework assignment due on Thursday. And what we generally have you do is you come in, you put your name and your section number on the homework. So if you don't know what your section number is, look it up. There's a lot of you. This is how we keep track. And then you turn it in up here with a pile for each section. You will also see here the weekly lab. Okay, there are 5 lab sections from Tuesday to Friday, 2 on Thursday. You all do the same lab. And then the lab report is due next Tuesday. If you finish the lab report during the lab, you can turn it in then. But the due date is next Tuesday, again in class. So where do you find these things so that you can turn them in and do your assignment? That is the question. And the answer is back here. Okay? So lectures, you can find these slides. All right? And there will also be a link to a video of this, but just because there's a video doesn't mean you can skip class. That's why I do quizzes. It's one of the reasons why I do quizzes. Okay, so this just gives you the first homework, and you click on it, and it downloads. This is due Thursday. And I would suggest you do this pretty soon. As I said, it's pretty easy, and also there's one part of it that will help you prepare for this week's lab, right? And for the class on Thursday. Okay, so for this week, the first lab, there's actually 2 different assignments that you're going to do, and it is your responsibility to have these printed out before you go to your lab section. Okay, those are the most urgent things. Okay, so one of your homework problems is to do a thorough read of the syllabus and come back with questions. So I'm just going to go over highlights. We have the course objectives, homework and lab reports, quizzes. As I said, I will do quizzes many of the mornings, starting first thing. There's a final project that we'll learn more about later. 2 midterms exams and a final. Our final is on Saturday, by the way. So that's cool. Grading policy. The honor code. Don't cheat. Like, really don't. Though I will say, I had a student once who came up to me after exam and told me, you know, I'm sorry, but in a moment of weakness, I looked at someone else's problem and someone else's answer, and I wrote it down. And all I said was, okay, we just won't count that answer. And then we both went on with our lives because I appreciated that he had been honest with me. Also, the person he copied from got it wrong. So. Yes. But another thing I have appreciated is some of my classes when I was an undergrad, we had take-home tests, which I really appreciated that level of trust. We're not doing that in this class just because I think you'll actually appreciate having the exams over in an hour, but it's something I like. Okay, if anyone is sexually harassing you, including me or the TAs or anyone, you do not have to stand for that, right? So there are numbers here for people you can call. So that's good. And student disability. There is an accessibility center. Again, every year I get emails from the accessibility center that say things like, so-and-so student has these issues and you should accommodate them, right? So, and you can also just talk to me, but I appreciate the sort of formal way it's done. And this includes things like ADHD and test anxiety. All right. So, if you have any questions about what I've just said, let's take 5 minutes for them before we dive back in. engineering.
Are labs done at each class or are they at?
So the labs, the activities are done during the lab session. That's what they're for.
Okay.
And you'll probably start filling in the report as you're doing it. If you finish during that 2-hour lab session, you can turn it in then, or you can finish it up after. Yes?
Do the labs typically take the entire 2 hours?
Not typically. Some are longer than others. Al, what would you say?
I'd say most of them do. Towards the end, start not taking the whole time. But I think the first one, I don't think we'll use the whole time.
Okay.
What's the curving policy?
What is the curving policy? The curving policy is I say this under grading, so I don't really curve the class. If it's really low, then I might bump things up a little bit. I will never curve you down. But the reason I do that is sometimes I'll be like, okay, I thought this exam question was going to be easier than it turned out to be. And so then I might just bump you up or give you an opportunity to make up or something like that. Yes?
You said there's a section number we need to put on our, where would we go to find that?
So on the class roles on my BYU, it should be on your class set schedule, I think. I don't know. Yeah.
Also, if you go to Learning Suite, it'll say which section you're in.
Okay. Yes.
Does the section number also have to go on our labs?
Yes, it should. As I said, it's part of bookkeeping for us. Yes.
Where do we find our section number?
Okay. Learning Suite or your class schedule. Yes.
So do you want our names or our ID numbers on our number?
Names. I don't know your ID numbers. I will never know your ID numbers. Okay, yes.
Did you say we had to print out our lab reports and lab sheets before lab?
Yes.
And we find them on this website?
It's a sheet and includes, it's on this website, it's under labs. You will know which one you need because it's on the schedule. It's a sheet that includes both instructions and places where you fill out the answers for the report. Yes.
So are we always seeing your labs on like printed paper, or are we expecting to get like lab books at the moment?
On printed paper, though I like that you're thinking about lab books. That is good policy. If you ever work in a professor's research lab, you should do that. But we give you printed paper that you print in. Yes.
Test more multiple choice or?
They are open, well, I usually do a little multiple choice section at the beginning, then open answer. Engineering classes will usually be open answer, right? Among other reasons, a lot of us like getting partial credit, and also a lot of them are big, complicated problems. You need a lot of math, multiple choice. One thing, the right answer is there on a list that's giving you too much. Too much. All right. Okay, so, as I said, part of your homework will be reading the syllabus in detail and coming with any questions on Thursday. So if you have more questions, we can talk about them. I want to use the rest of the class period to talk more about engineering. There we go. Okay, so what is engineering? Let's ask Neil Armstrong. By the way, astronauts are generally scientists and engineers. They have to be, because the reason they're up there in the first place is to do science, and they're only being kept up there and alive by being surrounded with engineering. So, that's Frank.
I am, and ever will be, a White Sox pocket protector nerdy engineer. Born under the second law of thermodynamics, seeped in the steam tables, in love with free body diagrams, transformed by Laplace and propelled by compressible flow. As an engineer, I take a substantial amount of pride in the accomplishments of my profession. Science is about what is, engineering is about what can be. Engineers' entire existence is dedicated to doing things better and more efficiently. It is a profession which leaves its imprint on our society in countless ways. A century ago, the world really needed improvements in quality of life, health, mobility, and living standards. At that time, life was a constant struggle. The 20th was a century often punctuated with the terror of war and darkened with societal struggles to overcome injustice. But the 20th was also the first century in which technology enabled the tenets and the images of those traumas to reach across the world and touch people in ways that were previously unimagined. Engineering helped create a world in which no injustice could be hidden. Many will look back to see how we have changed and what we have accomplished. The future's a bit foggy, but it's not unreasonable to suggest that the 21st century will enjoy a rate of progress not unlike the 20th. It's something to hope for.
All right, I like that video a lot. It is very inspiring. But also, amid the inspiringness, there is actually a nice...
This is the launch of Apollo 11, July 16, 1969. It's camera E8, which should...
Go away. Okay. Okay. There is also a concrete, this short and small definition of engineering here, right? He says science is about what is, engineering is about what can be. It's very poetical. What does that mean in practical terms? So now we're going to do something that I never liked doing when I was a student, which is we're going to break it into small groups and you're going to discuss this question. What does that mean in practical terms with each other? I never liked that because I like being, just myself, right? Don't like it in Sunday school either. But I have been converted to thinking it really helps learning by making sure you think about things and put them into words. So, little groups, 2 or 3, next to each other, discuss. What exactly does this mean, that engineering is about what
Summer. It was good? Yeah. How are you? Doing good. Did you conduct your clinical this summer? No, I didn't. I was taking some classes and I got the grant. Oh, really? Yeah. Nice. Good. Don't worry about it. Did you? I just finished. Okay. Awesome. Are you going to the lab today? So I can. Okay. I didn't realize. Yeah, so did you apply for this job? They sent me an email that said they were doing it 3 TAs. Oh, really? There you go. So we'll probably the 4 TAs. So we'll probably have to take 2 sections. So we'll probably I can take all of those sections except for the Friday one. Today. Okay, great. As far as I can tell, I have a class for the lab section today. It might be able to come for 2 hours, or like 1 hour, one of them. Okay. So I'll get that. Yeah, we'll do it on schedule.
Then there was something else that he said that I also liked, which is an engineer's entire existence is dedicated to doing things better and more efficiently. And one reason I like it is that he talks about efficiency. A lot of people think efficiency is not a very fun word. If you criticize something by calling it inefficient, a lot of times people just say you lack vision. I think efficiency is good. and important and inspiring, which again is one of the reasons I'm happy to be an engineer. So again, we're going to have another discussion, a couple minutes, and then about why efficiency is important and good, and then I'm going to give my answer at the end. So again,
materials, engineering, safety and environment. Taking econ type and electrical engineering 301. Like career skills class, 291 and 391.
Yeah, no, for me, right after this class,
That's it.
oh no, I have a class exam. Are
you going to join the new engineering?
just to go to the office. It's pretty cool. Have you? Yeah, it's nice. It's super nice. Lab space is really kind of random. We help them do stuff over from yeah, I can show it to you. But they had a really hard place to put everything. Said it's aesthetically pleasing, but it's not very functional. Are you going to keep working with Dr. Huss?
Yeah, I think so.
Yeah, cool.
Probably be pretty busy.
Yeah.
Do as much as I can.
Yeah.
What class did you take?
So I'm going to take PChem, taking the 311, the health and safety one. I'm taking fluids. Have you already taken fluids?
Yeah, I took it a semester.
Okay.
Dr.
I'll give you about a minute and a half, but hopefully you manage to have some thoughts in that time. Here is my answer for why efficiency is important. To make something more efficient essentially means to do the same things using less stuff, less time, less energy, less manpower. And time and energy are important. We only have so much of it, right? And anything we can do, anything to preserve any amount of it is going to help make the world that much better. Right? And that is why I believe in efficiency. By the way, if you look at the amount of energy that is used by the United States, huge amount, or the world actually, huge amounts of it is just lost, right? Lost to waste heat. That is a matter of efficiency. And being able to improve that by making things more efficient can do more to conserve energy than many of the other things people are excited about doing. Okay, but what is chemical engineering specifically? I took a definition from Wikipedia. It's pretty similar to the one in your book, actually, so it's pretty good. Will somebody volunteer to read this fluff text? You on the front row.
Chemical engineering is a branch of engineering that applies physical sciences, life sciences together with applied mathematics and economics to produce, transform, and transport, and properly use chemicals, materials, and energy. The chemical engineer designs large-scale processes that convert chemicals, raw materials, living cells, microorganisms, and energy into useful forms and products.
All right. So there's something about this definition that I noticed, maybe you noticed as well. It kind of sounds like chemical engineering is you do everything to everything using everything. And in a lot of ways, that's kind of true, actually. So that chemical engineering is incredibly versatile. That's one of the reasons I liked it, especially when I was a young student like you, and I still was not quite sure what exactly I wanted to do. So mechanical engineering, civil engineering, and electrical engineering, in general, tend to use math and physics. Chemical engineering adds on chemistry and biology, really covering the whole space. And because of that, you can see chemical engineers working in many different fields. the most typical chemical engineering job, the one people imagine in their head if they think of a chemical engineer, is to work in a chemical plant, making various chemicals that we live our life with. A lot of those are derived from petroleum, some aren't, and that it usually looks a bit like this. Okay. I mentioned that my father was a chemical engineer, so there was a plant like this just outside our hometown where he worked. And when I was little, we would drive past, and I would see all the lights all over, and then I would see there were these man-made ponds all around it where they processed the waste in order to get water that they could release into the wild at the end, right? And the lights reflected in the water. It was so nice. I thought it was beautiful. I called it fairyland. Right? And I still think they're pretty. So chemical engineering can also cover petroleum engineering more generally. We have a reservoir engineering class that's graduate level, but which some of you might want to take at some point. Okay, nuclear power. BYU does not have a nuclear engineering major. We cover it. We have a professor who is a nuclear engineer. We have nuclear engineering electives, and a lot of the same skills and knowledge you will learn as a chemical engineer could cross over into nuclear engineering as well. Environmental protection. I tell people this all the time. If you are a true believer in protecting the environment and eliminating pollution, this is one of the best things you can possibly study. Among other reasons, you can learn, first of all, just cleaning stuff out of water and air is classical chemical engineering. It's a separation. You got to know chemistry to do that. But another thing, understanding how industry works and the things that we rely on are made will help you understand how to, perhaps to do so in ways that are friendlier for the environment. Industrial plants hire people, engineers, often chemical engineers, in order to make their processes more environmentally friendly. It's good. Okay, semiconductors. IBM, Intel, Iron Flash up in Lehigh. All of these are semiconductor companies who hire chemical engineers all the time. See this? So these pictures are from what's called a fab. Everyone is wearing what's called bunny suits because flakes of skin and hair will ruin the product because everything is that small. All right? This is covered in all of these layers of different chemicals, all carved with tiny, tiny patterns. Chemical engineers help to do that. Food. Food is chemical. You're transforming it into a useful form. Remember the wiki definition? That's what happens when you make food in a big factory. Materials. Everything is made out of stuff. Okay? What you see here is this is just a couple examples of different materials of different kinds. Ketchup, which behaves strangely, the sticky stuff on sticky notes, the absorbent stuff in diapers. These pipes are probably made of PVC, which is a type of plastic. All right, help me out here. I don't know what people know. Who knows that there's lots of different kinds of plastic? Most of you? Okay, that's good. Yeah, people do know things. Okay, and so chemical engineers, again, BYU doesn't have a material science major. We cover it. So chemical engineers sometimes study developing materials out of molecules. But we are also the ones who produce and create these materials, the stuff everything else is made out of. Pharmaceuticals. All right, so I actually have two different pictures here I want to point out. Here we have someone working in a lab, probably developing pharmaceuticals. This is something a chemical engineer could do, but probably only if you go to graduate school and get a PhD. This is a factory making pharmaceuticals. Notice in a lot of ways it looks a lot like that chemical factory from earlier, right? Yes, because if you want your medicines to go out to the world, you have to make enough of them. And chemical engineers help with that. Medical devices. Again, we do not have a biomedical engineering program here either, so we cover it. Again, also, what we see here are a couple sort of classic biomedical devices. This is dialysis. That blood is having all of the stuff and toxins and badness cleaned out of it because this person's kidneys could not do it. This is an artificial heart. All right, both of those involve chemical engineering principles of various kinds that you're going to learn this semester. All right, so this wheel is in your book. Again, it sort of shows the broad areas. I would also like to point out that law and medicine are on here. Every year we have some of our graduates go to law school and medical school. This is good preparation while people go into patent law. Nice. Okay, so those are all areas chemical engineers cover, but what does a chemical engineer do? All right, so that is also very flexible. So if you're trained as a chemical engineer, you might end up doing research. So again, often that requires graduate school. You might do design, management, business. I know people, multiple people who get promoted out of engineering into being a manager, go all the way up. There are CEOs right now who used to be chemical engineers, mostly chemical companies. Okay, safety or environmental control, or process operations engineer, which again is kind of the classic thing for chemical engineers to do. And what does that mean? So, remember my dad again, who was a chemical engineer. This is him. He was young, and it was the 70s or something, and he had hair like the Beatles. Anyway, so he tells a story about when he was just starting out as a process engineer, probably about 25. So his plant was using too much of an expensive stabilizer. So their accountants were predicting they should be using this much, spending this much on it, but instead they kept using more. And so he was told that he needed to fix this. So after investigating, he found that the accounting recipes were different from the manufacturing recipes. So the accountant said, oh, we need to use this much stabilizer to create this much product, and it should cost this much. But that was actually less than the amount of stabilizer that was actually needed. Okay. So he told his boss, all you need is a better system for loading and checking the accounting recipes, right? So to make sure that from the beginning they matched up with the manufacturing recipes. His boss said, I have a better system, I assigned it to you. Okay? He was supposed to figure that out. That was his job. An engineer is the better system. An engineer fixes problems, makes choices, improves processes, and generally figures stuff out. Right? It's often a very open-ended job. It's a job with a lot of self-control and a lot of responsibility. Again, that's the reason it can be very exciting. You get turned out on these open-ended problems, and there's no map to follow, no checklist to go down. You just have to figure things out. If things are broken, you need to fix them. If things are not broken, you need to make them better. And you don't know how that's going to happen. And yes, as I said, in many ways that's exciting. In some ways, it's a job that sort of, you have to have ownership over your job in order to be a good engineer. Okay, so I'm going to close out, and then we're going to leave. It's going to be about 10 minutes early, 5 minutes early. So I'm going to close out with this quote from Brigham Young, after whom the university is named. And I'm going to read it this time. Let us train our minds until we delight in that which is good, lovely, and holy, seeking continually after that intelligence which will enable us effectually to build up Zion, seeking to do the will of the Lord all the days of our lives, including our minds and all scientific and mechanical mechanical knowledge, seeking diligently to understand the great design and plan of all created things, that we may know what to do with our lives and how to improve upon the facilities placed within our reach. Can you see why I like that quote? Yes. All right, here's the thing. Chemical engineering might not be for all y'all. Okay, some of you it probably won't be. You get people every year to switch to something else. But if you do stick with us, we will learn scientific and mechanical knowledge, and we will learn how to take what we have been given and turn it into better things. All right, thank you all. See you on Thursday.
Thank you.